So I'm VP of Product Management for Veeam. Actually, I'm just for 3 days now. I used to be Director of Product Management.
But, promotion.
Yeah.
But
also,
simple version. Yeah.
I'm both VMware vExpert and Microsoft MVP virtual machine, so I'm as unbiased as it gets in that hypervisor war, right?
So how do you feel about Xen?
Well, I heard even Citrix doesn't feel good about it because they're not gonna move it forward anymore, right? They passed it to some open source organization now, right? So I think that's a good answer. So
moving on.
Yeah, Citrix doesn't believe in it, right? Just for a start, yeah, I'm going to talk a little bit about backup copy jobs, which is definitely not any kind of breakthrough, but it goes along with built-in WAN acceleration. Just so you understand, built-in WAN acceleration and that architecture is actually a separate piece in Veeam, so it's actually going to be applied to replication as well in the next minor release, right? So it's not completely tied up to backup copy jobs, but with version 7.0, it's going to be only available with backup copy jobs. Why people copy backups? It's an interesting poll from our forums, right? So, as you can see, 85% of people do have at least one copy of their backups, right? That was surprising that many of them actually keep more than one copy, right? So they invest in that storage to keep multiple copies of their backup. And obviously, it's because you can't get away possibly with a single copy, right? And your backup software bugs out, you lose the storage where in the production data center where backups are stored, you can't recover. The more copies you have, the better the chances are for recovery, right? Yeah, and the way people are doing it today, essentially, depending on the solution, I can tell you how they do it with Veeam, but other solutions are very similar, right? You can just take your backups and copy them, right? What's the problem with this scenario? With this approach is that there is no integration, right, with your backup solution, right? Because backup software may have your backup files locked, and then you have issues, right? But also, this way you're kind of stuck with the retention you have in the primary side. So you may be backing up 1,000 VMs at your primary side and have those backup jobs creating multiple backup files, but you only want to create copies of 10% of those VMs offsite, right? That kind of forces you to re-architect your current backups and always keep in mind that, okay, in this job, I only want to put VMs that have to go offsite, right? And you always have to think about it. Automatically means that you cannot set up the jobs in a way that they use containers or VM folders because some other VM gets into that folder, gets picked up the job, goes over WAN, clogs your network, things like that. It's no flexibility. Or you can just set up a regular, the separate job that would go offsite, for example, right? And Veeam has actually been always pretty good at remote backup because we have two-agent architecture. We have the agent on both source and target side. We call them data movers. So they can talk each other over the WAN network, right? They have various WAN optimizations. They can compress the traffic. So it was working reasonably good with Veeam always, even until this version, right? But we still wanted to do something to improve that performance over the WAN, right? But before we talk offsite backups, let me just explain quickly how our new backup copy jobs work in Veeam and how they solve some issues that I explained about earlier. So it's not literally a backup copy. So it's not about taking your complete backup file that contains hundreds of thousands of VMs and moving it to some other location. It does use the backups as a source, but you can pick and choose what VMs you want to copy as a part of jobs, and you want to set up separate retention policy on that, right? So you can do daily backups on site. You can only do a weekly copy off-site, for example, right? Or you can things like that. So you can mix and match VMs, and you can pick and choose the retention policy. They can be absolutely separate for backup copy jobs. We even support GFS retention, so father, grandfather, son retention when you want to maintain multiple full backups for like yearly, quarterly, monthly backups for 3 or 5 years. That's also part of a backup copy. But most important, what I like to talk about is I think the most important thing about backup copy jobs is that they allow implementing what I call the ultimate virtual machine backup architecture. Because virtual machine backup is very unique in a way that data sets you have to deal with are immense in size, and backup windows are really short because VM backups use snapshots, and you don't want a snapshot commit go into your production hours. So that's kind of two things they have to deal with: immense data set on one point and a short backup window on another. And how you solve it? I think it's going to be better if I draw it. So say you have your ESX host or Hyper-V for that matter in your production, and you have your backup server here. The backup server pulls the data, right? And you wanna, that's the and stores it in a backup repository, disk-based backup repositories. Veeam Backup is a disk-to-disk backup solution. If you want to tape, it's going to be disk-to-disk to tape, right? We don't write directly to tape because of backup file format. It has built-in deduplication compression. It's not like a stream that you can write to tape. It requires random access. And that's what you want to do really fast. So you have a lot of data here and you want to store it here really fast, right? And then after you do that, you also want to create your backup copies, right? And let me put it here. It's fast storage. It's a slow storage. When I say slow, I mean some storage which has generally very low cost per terabyte, like deduplicating storage, right? They're generally not as fast as raw disk storage, right? So that's on-site copy, and you may want to do off-site copy as well, right? Do some other storage, right? And that's where backup copy jobs really come into the picture, right? And so the ultimate VM backup architecture is actually to designate a very fast storage as your primary backup target, right? But only keep a handful of restore points. That would be sufficient, for your daily operational restores. Like in 99% of cases, you will restore from latest restore point. Maybe in other 1% of cases, you will restore from like last, 14 days. Everything else is very rare restore, right? Very rare, happens very rarely, right? So if you back up to very fast storage, then you are able to get that immense amount of data and put it into your backup repository really, really fast within a very short backup window, right? And then you have, depending on your schedule of backup copy jobs, you have lots of time to actually take this data and write it to either slow deduplicating storage or put it over WAN link offsite. Maybe if you do it once a week, you have 7 days to put it there. So that's actually the architecture that will allow backing up really, really big environments on a very, very short window. Again, invest in very fast storage, but don't for your primary backup target. Don't make it very big because you want to only store a handful of restore points. And to meet your archival requirements, if you want to back up, maintain for 3 years, by exagrid data domain, copy backups on site, take it off site to your other site over WAN. All the options are there for you with backup copy jobs.
So Anton, I know some environments that I've worked with like to do their primary backup directly to offsite, partly to fulfill legal regulations. Is that possible?
Yeah, we always supported like backup direct. You can back up direct to slow target, right?
Yep.
It can be your primary target.
Which can be in a remote site.
Yeah.
But will that support the WAN acceleration capability?
WAN acceleration, it's part of backup copy, right? It has to deal, when we're going to be talking about backup copy and how we actually make it faster than general purpose WAN accelerators, you will see that it actually requires that data is already there, right? So it can't really pull it from the source, from the host, right? It has to be already stored in a disk.
Yeah, so when 6.0, when we released that with our new architecture, with the proxy and repository, what that allowed is essentially WAN optimization, because you had the proxy on the source getting the data, doing a compression and dedupe, and then sending just that data over to the target repository. So that was optimized, but it wasn't accelerated.
Okay.
So with version 7, the acceleration will be in the backup copy. We'll introduce it later for replication, and we may, if that's an important use case for customers, then we'll look at adding it for the backup then as well if possible.
Okay.
So previously, again, we discussed that backup copy jobs, and WAN acceleration in version 7 is only applies to backup copy jobs. Again, next minor release, we're going to apply to replication. I have already have some crazy ideas how we can actually apply it to some other things like quick migration functionality that is also something that's available for free in free edition. We can potentially accelerate that, and it's surprisingly popular, right? People like to use quick migration to move the VMs around for when vMotion is not licensed or just doesn't work well because of networking problems. But specifically to WAN acceleration, it's another poll I just had now forums for 1 month ago, and I asked how you take your backups offsite, right? And as you can see, tape is actually 1/3, still 1/3. And by the way, these numbers, they don't add up to 100. I was too lazy to recalculate them because there are some few people who still don't do offsite backup, right? But the main point is that with version 7, we address all these, all those 4 ways of taking backup offsite. So 37% of people copy backups over WAN. That's a popular option, and that's what we do internally at Veeam. I'm going to talk more about that. Just set up dedicated job pointed to remote repository because of our efficient architecture that uses 2 data movers on both sides. Works reasonably well. Tape is 30%, 32%. Rotated drives. Well, again, because many of our customers are small businesses, that's a big result. 22%. Just do rotated drives, and that's actually how we started doing backup offsite backup internally 5 years ago when I just joined Veeam. That's the process we had. So we went through that, copying backup files to another site using rsync, Robocopy, copying backups to the cloud edition, things like that. Just 2% actually on the forum poll. Syncing backup repositories using storage-based replication, that's effectively goes again over 37%, but just using storage capabilities. And 7% of people don't do offsite backups. And we're going to focus, And I think it's a good time to tell a story why we actually started implementing that. So we at Veeam are doing remote backup from our office in St. Petersburg, Russia, which is where our R&D is. And also we have some sales offices there, so it's part of our support organizations there. We needed to take and as we started, as I explained, our CTO basically would do those external hard drives, rotated drives techniques when every Friday they would take the hard drive home, right? As the company grew, we didn't want to manage it manually anymore, so we opened our office in first US office in Columbus, Ohio, and we started just created a remote backup job that pointed to a remote repository in Columbus, and we would back up over Atlantic. And we've been doing it for 3 years now, right? And I'm actually one of the administrators of our own backup deployment, and I get those emails every day on how job complete. And we've been backing up this way just a handful of most critical VMs. We simply couldn't do it more than that. We'd like to, but we could only dedicate about 6 megabit per second bandwidth to our remote backups, right? And that was enough to only back up, just a handful of VMs. We really wanted to back up all of them, but we had to pick and choose like 2 or 3 most important VMs to do that, right? And we just wanted to build something that we could use ourselves to, without extending the bandwidth that is completely cost prohibitive for our office, for where our office is located in St. Petersburg. To use same bandwidth of 6 megabits per second, but instead of backing up 2 or 3 VMs, do like 30 or 40 VMs, and that would cover all the infrastructure in our St. Petersburg office. So we wanted to build something that we can use ourselves. And let's talk a little bit about WAN Acceleration 101 for those who are not familiar with it. And it's also going to be interesting for you to see how we are different from guys like Riverbed, Silverpeak, Cisco. They all have those WAN acceleration solutions. So how typical WAN accelerator works. It's also a good time to draw. So you have some data in your source side, and it can be and you need to get it to another side. So you put two boxes. I draw them with squares. And they talk to each other, and all the network traffic goes through these boxes, right? And that's where the magic of traffic reduction happens. And then the data is rehydrated on the target WAN accelerator and put on wherever it needs to go on target, right? The main idea about general purpose WAN accelerators and the way they work is that they have so-called, cache, where they store the blocks of data. Yeah?
You've got your button on.
You're clicking.
Yeah.
Click happy.
What?
Just give it a good, we can fix it.
Yeah, the marketing guy can fix it.
There you go.
Yeah. I'll
Forward.
So, and I'm going to be talking about specifically to copying backups, but of course, because they're general purpose, they can accelerate any types of traffic. So it can be exchange traffic, RDP, VDI, whatever traffic goes through that network. They can accelerate it, but specifically to copying backups or replicas. As you start copying the data, accelerators kind of start to learn the data feed, right? And they start to, pick the data blocks that they see are transferred more than once, and they started caching it in this cache, right? So the next time they see the same block, they'll, source accelerator does, okay, source accelerator kind of says, okay, I know this is known block, and you already have that. So instead of transferring that, just take it from your cache. So it's a pretty simple paradigm, right? Just start learning the traffic, have a smart algorithms on how you give priority to different types of blocks. For example, if the block has first appeared, give it high priority because it's a good chance that it just appeared in source environment, it can be transferred again, right? Obviously, if a block is transferred again, then it gets even higher priority. If it never transferred again, then it drops out of global cache, and you can just free it up and cache some other block and see how if it may be the common block. So a few things you can expect from any general purpose WAN accelerator is this kind of global caching is variable block size dedupe because you want to populate this cache in most effective manner. You don't want to use big chunks. You want to or fixed block sizes because it's not very efficient deduplication this way. So it's a variable block size dedupe. Traffic is almost always compressed with the general purpose WAN accelerators. There is different sorts of WAN optimizations on top of TCP/IP. Some accelerators will just kill the TCP/IP connection, transfer the data using some native, UDP or some native protocol, and then recreate TCP/IP connection and let it go through on the other side, right? So all the things you can expect from general purpose WAN accelerator we provide as well, right? What is our special sauce with Veeam? Well, I like to say it's content awareness, right? So because our WAN acceleration is not general purpose but built into the product, it actually understands the data that it synchronizes, and that gives us a couple of benefits, right? If we take this picture to Veeam now, right, this is a backup repository on a source, and this is backup repository on a target. And we and Veeam, actually, unlike these accelerators that have to learn the traffic, we already know, we already understand what's in there, what's in that backup repository, right? So for example, let's say before you started your remote backup, you seeded the backup file to this site, right? So when we see the block, and when we started backup copy, we started sending the data blocks, source accelerator doesn't yet have that global cache populated, right? and because we just started that. So normally it would have to learn it. It would have to transfer it, then that's how that block will get into this global cache, into this cache on target side, right? Instead, with Veeam, what we do if we don't find the block in the global cache, right? I can actually look up the target backup repository, see if it's already there, right? Because it may be seeded already there, right? So immediately, if you just put a side by side and starting copying the data, you will see that there's going to be a lot of copying happening with generic WAN acceleration. But with Veeam, there will be only actually deltas comparing to what is already located in the target backup repository. So think about it as I like to call it infinite cache, right? If it's if this backup repository on target has 10 terabytes of data, that means that target and source one accelerator have access to 10 terabytes of data they can use as a global cache, right?
But the thing there with it, like WAN acceleration always works on fingerprinting so that you can find out. So it's a smaller amount of data that you understand is a duplicate.
Yeah, it's what I call variable block size dedupe. You call it fingerprinting. That's essentially the
So what is the mechanism that you're using? How are you tracking the degree of sameness between the two sites so that you can actually do that acceleration? Where is that stored?
Well, that's
it's in two areas, right? So we have our repositories as kind of one level of cache, and then we will still have the caches that he has there. There will still be caches there as well.
Okay,
And
so that's sort of like the transfer cache, like your riverbeds and that sort of
Yes,
thing.
correct.
Yeah.
So you have that as part of the product. But then,
Yeah.
so this backup repository, so again, forgive me because I'm not super up on exactly how Veeam works.
Uh-huh.
So this backup repository you're talking about is the WAN acceleration repository?
No, so
No, it's native.
backup repository is our term. So when you set up a backup job, you send it to a backup repository.
Yeah, which is what I thought
Yep.
it was. Okay, so that is the actual destination for your
Just,
backup data.
collection of files.
So are you kind of
it's a backup server
adding
that writes.
fingerprints into your transfer repository?
It's
then?
there in our backup format.
Okay, so
Yeah,
that
because-
has a
yeah.
little header thing to say this variable block
Our
size
backup
is
file-
X.
Yeah, our backup file is essentially single instance block storage that has a deduplication built in, right? So each block actually has a hash associated with it.
Okay, so
right?
you've already got that and you just went, hey, that's cool, we can do
Yeah.
blah with that.
Yeah.
And so you have a mechanism to go and interrogate the target and ask it, have we
Yeah.
already got this there? Yes,
Exactly.
go.
Exactly.
That's cool.
And the target has a lot more. That's important. It's not
Yeah.
a replication of backups.
Yeah.
In theory, on the left is very small, short, not that much storage. But then on the right, it'll be a long, deep archive. In fact, there may be blocks that come up, like this system got Windows Update this month and this one got it next month. I'm not going to transfer it over twice. I already did that, and it can pull it back up. It's very, very adaptive because we know what we're doing.
So is it safe to say that the benefit of this is assuming you've already got a lot of data seeded on the other side, sitting there, to where then you can reference actual blocks on both ends to...
Correct.
So initially, you can't get around the cold transfer. That has to happen.
The first,
No matter
The cold, like you said, the cold transfer, you can either copy it, do an initial copy, and do it that way, or you can still do the truck method, right? You can put it on tape or disk and send it over and see the target repository that way as well.
You can actually, there are, I just didn't get to it, but there is also some improvements that we deliver even to the cold transfer, but we'll get to that. So it's a good point as well.
This is like having an incremental instead of a full backup, except it's the next stage beyond incrementals.
Yeah.
Yeah, that is very cool.
But the biggest point here, I guess, is that both generic purpose WAN accelerators and our Veeam acceleration has this smaller global cache, that where you learn the blocks, where you put the blocks as you learn them, right? Also, even here we have some improvements, right? But what a general purpose and WAN accelerator doesn't have is access to much bigger cache, which is your backup repositories. So first thing is the infinite cache, and then the second thing, again, how do you prioritize which block go into these smaller caches? And these global caches that WAN acceleration uses are actually fairly small. You're not gonna get a WAN accelerator box with with a disk of in terabytes of backup, where you can put the terabytes of data, because that would simply affect the performance of WAN acceleration, right? So those WAN accelerator boxes, they typically have very small caches, just a few hundreds of gigabytes. And it's very important that you have a correct logic, what blocks. First, fingerprinting has to go on a small block level because you don't want to waste space, by putting very large blocks there. But also, how do you prioritize which blocks, actually go and take place into this cache? And also the other thing, because they're general purpose and you accelerate multiple traffics, there is constant competition going for this cache, right? Because there is also RDP traffic, there is, some user activity, I don't know, with users just browsing internet maybe, and all of that stuff actually goes and competes for that global cache. So with Veeam, first, there is no competition for global cache because it's our own global cache, and it's completely 100% dedicated to backup traffic. But also, we call that cache content aware. So when we transfer the data, and when, for example, initial transfer happens, right, we are actually able to drill down and understand that, okay, at this time it looks like we're transferring data blocks that belong to operating system disk, right? Those blocks absolutely have to be given lots of priority over other blocks, right? So for example, you put the performance of this cache is actually almost always going to be the primary bottleneck. So you want to put it on SSD drive, and SSD drives are, they're not too big, right? So for example, you put it on 128 gigabyte SSD drive. How use these gigabytes in the most effective manner, right? Again, it comes down to prioritizing what blocks live there and what blocks gone and free up the space, right? And because we are aware and understand that what we're transferring, we give that blocks belonging to operating system, much higher priority. So the next time, maybe you transfer the VM, you do without seeding, you do cold transfer, you transfer a single VM, and you have to transfer it completely. But the next VM goes with the same operating system, and you don't have to transfer any blocks that belong to operating system again. No matter how small the cache is, no matter how much space there were there, those blocks will be given much higher priority, and they almost always will be there. But in one other thing, how you can accelerate the cold traffic, cold replication, cold copy, the first copy, is it's interesting hack as well. You can actually, with Veeam, you can actually pre-populate this cache, right? So you can emulate the same backup copy on site, right? And your cache will be populated with the data from all operating system you have in your environment, right? Then you take that cache and just copy it into the cache in your production deployment, right? And then there is no even learning. Learning is not needed. The data is already there. So again, some capability you cannot really do with native environment.
Yeah, that's one of the hacks you mentioned. So essentially, learn between two without going over the WAN, and then that cache can be copied to any other WAN accelerator role and used as its cache. So another way to increase the.
So just a point of clarification to make sure I understand the architecture here. The difference between you and Riverbed, Cisco WAS, any of the other, Blue Coat, whoever, is that you have basically a WAN op type cache on your source and target there, but you're also able to reach down on both sides into the actual backup record and say, if I'm sending this, I can basically make another communication to the other end. And so will the backup record in turn on both ends start flooding the actual cache, or does that not even come into play? In other words, if I've got a file on one side, one on the other, and I'm telling you on the other end, hey, this file is coming, you probably have most of this, does it bypass the little source target cache you have there and just go through Optimizer, or does it still have to get I guess maybe I'm not quite sure how you're.
I understand the question. Yeah. So okay, for performance consideration, this is how it works. So whenever we start transfer some block, first place we look it up is a global cache, because it's it's a kind of a local storage on WAN accelerator box, right? It's immediately available. It's very low latency. So we do look up in this cache, right? If the block is already there, again, only if the block has not been yet already cached in that global cache, right? Only then we talk to target to say, okay, look up in your backup repository, right? This will be generally slower operation with high latency because backup repository will, sometimes it will be local to target server, but oftentimes it will be also, on a NAS share, right? So that's longer. So first we look up in the global cache. If, the block is already in global cache, we just send it ID and that's done. We move on to the next block. If it's not here, then we look it up. If we find the block, again, we don't have to transfer it, but also as we process that block, that block may get put into global cache as well. Granted, there is a space for it, right? If there is space for it, it gets put there and gets a priority assigned depending on the block is this. Again, if the block appeared for the first time, it gets high priority because it may be some new file you want to cache. If a block belongs to the system state operating system file, we also put it given even higher priority, right? So it's a kind of two-step process. Global cache lookup, backup repository lookup, but doesn't matter whether we transfer it or not. We may also populate global cache with this block. And we don't have to read it from here because we already have it here, right? So we just pull it and put it in global cache. So that following times we transfer the block maybe faster. Okay. So other things on our special source, again, we do optimize TCP/IP. We do a lot of testing comparing TCP/IP, which is kind of known not to be a good protocol for high latency links, unreliable links. We compared with UDP, done a lot of testing. Decided not to go with UDP because we found that multi-threaded TCP/IP actually provides is better suitable to our workload. We did optimize around the fact that TCP/IP is very chatty, so we transfer it in very large block sizes, so there is very little chattiness, very little overhead of that TCP/IP traffic, right? So by default, we'll actually create 5 parallel connections, and that would it's usually good to completely saturate any WAN, but it's also customizable, so you can bump it to 20 connections in parallel, right? If you have some weird networking equipment that throttles every single connection, and so on, right? So that always provided. Funny thing that we completely almost nailed it because that decision not to go with UDP happened, a couple of years ago, and just a few months ago I read up some research on a Russian IT site, and a guy from Google Labs posted that they did exactly the same research comparing TCP/IP and UDP, and also found that UDP is not as good and as fancy as other people think. They actually also found out that 3-5 parallel TCP/IP connections and with optimizations, for it not to be chatty but transfer data in big chunks is actually better in most cases. So we completely nailed it with our research.
Okay, so you are using TCP, not UDP.
Yeah.
Okay.
We decided not to, and UDP. I mean, for some reason, many, especially open source WAN accelerators, they use UDP because people thought that it's much more efficient. But as soon as UDP also doesn't guarantee the delivery, right? So as soon as people start building on top things to match TCP/IP, it becomes also complex, and then there is no, there is the ways that you can optimize TCP/IP instead, and not go UDP and make it simpler in the end for everyone.
So you're just inflating your window size and
things like that. Yeah.
Using multiple
Connections,
to allow more data to be in flight at a time.
Yeah.
you said 5, but you can go
5 is default, and we
you can
just
go up to 20 if you need to.
Yeah. At least one customer I know, they use it to replicate data centers like between Europe, and they had to run it to 20. For some reason, they had throttling on each TCP/IP connection. Maybe that has to deal with some specific networking equipment that does that, right? I know we kind of have this issue as well with our connection between St. Petersburg and Columbus. Each FTP connection I open, it's limited to 1 megabit per second. I don't know why it happens, right? I open 5 connections, each of them upload with 1 megabit. I think it has to deal with latency and just generic TCP/IP.
It's the bandwidth product problem.
Yeah.
That TCP will only allow so much data to be in flight, and so if you send that much data and the latency is that the first of it hasn't gotten to the far end yet, then the ACK doesn't come back and you're sitting there waiting for the ACK and you can't send any more data because you can't have any more data in flight.
Yep.
Latency times the size of the pipe.
Is this a one-to-one relationship? In other words, if I want to replicate to multiple data centers from an actual TCP connection standpoint, would
So you say if you
so
have
a
another
multi-target, right?
site here,
Right.
another site, yeah, you can use the same. You have to put obviously accelerator in this side as well, but they can talk to the same one accelerator here.
Cool.
Yeah.
So would the
So
cache
this is HQ.
would the cache be universal or would it be like per peer caching?
Cache is actually not shared between, right? We looked at sharing the caches, but there is some performance impact.
I mean, in terms of I'm talking to multiple targets, do
What
you
do
have the same cache?
on the source side?
So do you take
to
the
service
riverbed
both
approach or do you
targets?
take the
There
Cisco
will
WAS
be-
approach?
Yeah, there will be separate cache here for each replication partner, essentially. Yeah.
Question from
You-
the
yeah.
internet. Can you sync the global cache with Dropbox?
I don't think that's a real.
I think it's
I think it was
It's
a
from,
real
one of their own,
yeah.
that's from Chris.
That was a joke.
And John, you should have substituted SkyDrive.
Yeah, exactly.
I
Yeah.
purposely didn't go SkyDrive.
Because we know that definitely wouldn't work.
Yeah. So of course we do on top
You
of
know what to do.
We do have another question, which
Yes.
I think is serious. Just to confirm, the data is coming from a backup repository, so a backup is required to replicate. I think the intent of the question here is that you have to have the backup repository at both sites,
Yeah.
so that the WAN acceleration will work, which is kind of what I was asking about before.
It's not necessarily, as Anton mentioned, if you're doing a cold copy, right, there's nothing on the target, we will still begin to optimize it, but you get more benefit if you have repositories on both sides already.
Yeah.
But if you don't have the repository on the other side, as that copy begins, it'll start building the caches, and you will still get some benefits, but not as much of a benefit as if the data was already over there.
You've just got more cache data that you can draw.
Correct.
Yeah.
So-
You've actually got you've combined both this kind of caching of backup data as well as what WAN optimizers do, which is in-flight data. So you've actually got both.
Yeah.
Yeah.
Yeah, they're going beyond riverbed or any of them because they can't. It's like you can see into the future, right, ahead of time what you're about to optimize.
Well, you're seeing into the past. It's like we did this already.
Yeah.
Right.
That's exactly.
And
I
for-
like.
Guys' plans, what's going on?
Yeah.
I very much like what you said because that what also happened on our development meeting when we just architected this thing, and somebody said, "Yeah, we'll always win them because they cannot see the future." I think
Yeah.
it's almost ideal way to explain that. Yeah,
Well,
we'll be always more efficient.
This is pretty much the ideal use case for this kind of solution. Is that the riverbeds, they're solving a different problem. They're actually
Yeah.
trying to accelerate in-flight data transfers, which is something that you can't ever have seen before, probably. Predicting the future that way is a lot more difficult, whereas this one, it's like we're doing backups. We back up the same data all the time.
And we know how we write.
Yeah.
Yeah.
So this one is just like you're backing up Windows. We already backed up Windows before.
But I'd say
Most
the-
of Windows did not change.
The caveat to that is with some of the WAN app companies, as far as application acceleration, like SIFs, if I can use that term, Exchange, SharePoint, they know how. Yeah. So some of the chattier protocols out there, they at least know on a basic level you're going to be vomiting out
Yeah.
all kinds of stuff. So let me just go ahead and
Well, it's just they're full of redundant data
right.
that
But
doesn't need to be.
there's nobody that can. I mean, you can't. Yeah, you can't see into the future.
Yeah. Well, this is pretty much saying that we backed this up already. Why are we backing it up again? So that's why I think that it's like even better than incrementals. It's like you're not just not backing up stuff that didn't change, you're backing up stuff that has never changed
Right.
and
But-
won't change.
But obviously, this has to work in conjunction with, the people controlling your WAN links and QoS policies, because you could still be potentially bottlenecked by all the other traffic out there that you may not deal with it on your actual WAN acceleration piece, but when you jump on the same circuit that everyone else is on.
Well, we do have SIS version 6, so it's over a year ago, right? We do have our own what we call global throttling, so you can specify the windows, the source and target IP addresses, and what is the maximum bandwidth. All Veeam Backup Replication activities can use it. It doesn't matter what you do, right? So that global throttling also applies to one accelerator. And that's what we use internally when I said that we dedicated 6 megabits per second for our own remote backups. That's how we did that. So we just set up a schedule that, 24/7, anything goes from this IP to this IP address cannot use more than 6 megabits per second, right? So, and that also applies to one accelerator transfers as well.
So you can basically help out if you have already a poorly configured network.
Yeah.
You can help.
Yeah, we
Not
can make sure we
pile
don't
on.
need the whole bandwidth because we can, again, with multiple TCP IP connections, we can eat all the bandwidth we can reach, right? But if you don't want it, you can throttle us down. It's built into the product again.
So, in interest of time, we want to talk about the storage snapshots now, real quick. And because it sounds like these guys want to talk about vCloud Director as well.
Maybe we'll start from one vCloud Director because storage snapshot is really simple, right?
Okay.
And I'll be drawing while he's be doing vCloud Director. I'll draw some schemas and that will make it easier to.
Okay.
Yeah.
That'll work.
Maybe, yeah, you can prepare just 5 more minutes again. So going again, how we're better than general purpose one accelerators. One other thing is when we're talking copy data offsite, it's obviously always forever incremental, right? Forever incremental is scary, right? Because you're storing data on disk, on regular disks. Disks all have these universal read errors, right? That enterprise SATA disks are better than consumer disks, but still it's pretty significant chance of error, right? Meaning you can, if you write like 4 terabytes of data, immediately read it back, you'll get 1 error on average, right? That's with consumer drives. With the enterprise drives, it's 1 magnitude better, so it's 40 terabytes. Still nowhere close to tape, which is 2 magnitudes better than enterprise SATA drives, right? But it's very, very, significant chance of error. So what we do,
And that's if you believe the vendors.
yeah. What we do as a part of backup copy jobs, we actually have an automated, what we call health check and remediation of our forever incremental chain. So we will periodically read all your backups on target site, again, hash them, send the hashes to the source and say, okay, let's compare if what you have is what I have, right? If we find some block that, we read and it didn't read correctly from the storage, we stored one thing and we read another thing. We said, okay, this block is bad. You have to transfer it over again when you do the synchronization next time, so that we'll heal that block, okay? And not only that, again, as a part of that process, we actually say, okay, if this block is bad, it's maybe not because of this storage is bad. It's maybe because the storage back in the global cache is bad. So let's also resync that block in the global cache in case it's corrupted there, right? And that's a SSD drive that potentially can also, if it's an SSD drive, can potentially also generate read errors, right, with time. So it's an automated health check and remediation, again, because it's integrated, because we're aware of the content that we're accelerating. General purpose one accelerators will not give it to you. Yeah.
My favorite thing about this, and those of you who have used Veeam, right, or any backup, right, you really struggle to get stuff off-site. My favorite feature or attribute right here is that this arrow right here is the only time we do the backup. So you think about your virtual infrastructure, right, the backup window, the snapshot. So actually probably the biggest benefit is it actually shrinks your backup window, because all of this, the pressure's off of your backup window. You're not putting a snapshot open on your storage, right? Or you're not, working in your backup window. So all of this really is outside of the backup window. So to kind of pull it all together, I really like that. It's my favorite feature of it all.
So everything I talked about is not cool. This is cool. Okay.